Large language models weaken the traditional relationship between reasoning and observable output. Students can now generate correct answers without necessarily engaging in the underlying reasoning process. coLearn-AI explores how collaborative learning environments can preserve reasoning through structured interaction and constrained AI scaffolding. What you are seeing here is a coLearn-AI in live classroom use. On the left is the instructor dashboard, which provides a real-time overview of group progress across the activity. On the right are two views of the same group workspace: the active student screen, where the group's current work is being entered, and the observer view, which mirrors the work as it unfolds. Together, these views illustrate how coLearn-AI supports collaborative problem solving, shared visibility into student thinking, and real-time instructor awareness during an activity. Students work in structured collaborative groups that enforce turn-taking. Only one student can advance the shared activity at a time, requiring groups to coordinate reasoning before progressing. The activity begins with prediction and experimentation rather than immediate correctness. Students first predict what the program will do before running it. The goal is not immediate correctness, but making reasoning visible. Here, the AI notices that the prediction is incomplete and redirects attention towards the loop structure and turning angle rather than supplying an answer. While only one student can submit to the shared activity at a time, students can independently experiment in sandbox mode. The output often surprises students, creating opportunities for collaborative explanation and refinement. Small changes in turning angle accumulate over time, producing emergent visual behavior. The yellow AI feedback box provides nudges rather than giving them an answer. Students then begin experimenting with individual parameters and observing how small code changes influence the emergent structure of the pattern. In this example, changing the turning angle from 89 degrees to 90 degrees dramatically alters the behavior of the drawing. Students collaboratively refine their understanding through structured turns, experimentation, and visual feedback. Different parameter changes produce dramatically different emergent structures. Here, the AI again avoids supplying an answer directly, instead encouraging students to connect specific parameter changes to visible outcomes. So here we see, as the students experiment with different parameters. Note that either student can run their own instances of the program and experiment individually. coLearn-AI preserves a persistent epistemic trace, an append-only history of predictions, revisions, experimentation, AI prompts, and collaborative interaction. The system captures not only what students answered, but how understanding evolved over time. This creates visibility into reasoning processes that are often lost in AI-mediated learning environments. Instructors can observe participation, activity progress, reasoning traces, and interaction histories across groups in real time. The system has been used extensively in 3 introductory programming courses, and additionally in advanced computing courses, including data structures, applied algorithms, and software development. The goal of coLearn-AI is not simply to use AI in education, but to design environments where AI strengthens collaborative reasoning rather than replacing it. Here we see the instructor reviewing the student's work, and here we see the epistemic trace of all interactions between the students and the computer.